Good morning, Year 2. It's Marvellous Monday of the very last week of your Year 2 learning. Now, we've got one more session about solving word problems, and these are even trickier than the ones that you did last week. But bear with me, give it a good go, talk about your learning, try and work it out in different ways, use pictures, use equipment to help you and see how you do. Let's start by looking at the in focus task. The boy is 8 kilograms heavier than the girl. Is it possible to find out how heavy each child is? If you look carefully on the scales, their combined weight, which means both of them together, is 54 kilograms. And I've made that a bit more clear for you to see. Pause the video and speak to your adult to see if you can find out how heavy each child is, or whether it's even possible to find that out. Now, your first thinking might be, okay, let's choose two numbers, two weights that have a difference of 8. So if we look at the Let's Learn 1, is it possible for the boy to weigh 28 kilograms and the girl to weigh 20 kilograms? Well, initially, you could think yes, because I know that 28, take away the 20, leaves me with a difference of 8 kilograms, which could be the 8 kilograms more that the boy weighs than the girl. However, remembering that together the boy and the girl weigh 54 kilograms, if we add the boy's weight of 28 kilograms and the girl's weight of 20 kilograms, we only get a combined weight of 48 kilograms. And 48 kilograms is less than 54 kilograms. We need that combined weight to be 54 kilograms. Talk to your adult about what we might need to do to the two weights we've already thought about in order to try and get a bit closer to 54 kilograms rather than 48. Is it possible then for the boy to weigh 30 kilograms and the girl to weigh 22? Talk to your adult and discuss. Hopefully you've agreed that it cannot be possible. And it cannot be possible because even though 30, which is the boy's weight, take away 22 kilograms, which is the girl's weight, still gives us a difference of 8 kilograms, which is what the question said in the first place, that he was 8 kilograms heavier. When we add them together, 30 add 22, our combined weight would only be 52 kilograms. And we need to remind ourselves that the combined weight for both the boy and the girl is 54 kilograms. Let's see how we would solve this. Now, we've got a bar model, or should I say 2 bar models, to help us think about and visualize this problem. So we know that together the boy and the girl weigh 54 kilograms. Okay, so the blue and the pink bar and the orange bar all together represent 54 kilograms. We also know that the boy weighs 8 kilograms more than the girl. So this pink part of our bar is the 8 kilograms more that the boy weighs than the girl. We can then see that we're left with a blue and an orange bar that are the same length. Pause the video and discuss why you think this might be. That's right. Hopefully you noticed this calculation here to help explain what is happening. And what we've done, is we've taken the 54 kilograms that they both weigh all together, and we've subtracted the 8 kilograms more that the boy weighs to leave us with 46 kilograms. Now, if we move on to step B and we eradicate, we get rid of that 8 extra kilograms. Okay, we can now see that our bar model represents altogether 46 kilograms. And there are 2 bar models of the same length. So what we need to do is we need to divide the combined weight of 46 kilograms by 2, because there is 1 boy and there is 1 girl. Now, to divide by 2, the easiest way is, first of all, divide 40, and 40 divided by 2 you should know is 20, and you should know that because 2 lots of 20 is 40, and then you can divide the 6, which is, when you divide by 2, the same as halving, so half of 6 is 3. Combine the 20 and the 3 together to give you 23 kilograms. And we can see that has been written here as an addition sentence, just to check that half of 46 is 23, because if we add 2 23s together, we make 46. So looking for a final answer then, we know that each child weighs 23 kilograms, but the boy weighs 8 more than 23. So if we add 23 and 8 together, we get 31. So the boy weighs 31 kilograms and the girl weighs 23. Let's have a go at another question that is similar. Lulu had some stickers. She gave away 25 stickers and bought another 30 stickers. She had 100 stickers in total at the end. But how many stickers did Lulu have at first? Pause the video and have a go at working this out, talking through your thinking with your partner, with your adult. Now, this is one of those problems where you actually need to digest the information you're given, and knowing that she had 100 stickers at the end is probably the most important information. And we're going to look at the bar model, but starting at the end and then taking a step back. So we can see that altogether she had 100 stickers at the end. So this third bar represents 100. And we know that the yellow bar and the orange bar represent the 25 and the 5, making the extra 30 that she bought. So the missing part of this bar then is the pink. And using your knowledge of number bonds, you should know that to get to 100 from 30, we have to add 70. So knowing that the pink bar now represents 70, we can rename that pink bar in our second step. So we know that she had 70 stickers to start with, and she'd given 25 of them away, so that's obviously been blanked out. But what we want to know is, if she didn't give those 25 stickers away, how many she had to start with. And we can see there that we've got 70 and 25, and 70 add 25 is 95. So Lulu must have started with 95 stickers. We're going to work back through it logistically now. If she gave away 25 of those stickers, 95 take away 25 is 70. And then if she had those 70 stickers and she bought 30 more, she had 100 at the end. So the answer to that one is Lulu had 95 stickers at first. Okay, so there are 3 guided practice questions I want you to have a go at. If you can pause the video after each one to talk about how you might solve this, I'll then go through a strategy that we would use in school with you to help you find the answers to them. Okay, Year 2, this has taken me a while to work out, but let's see if we can work through this with you. So I'm going to draw a rough bar model because Charles has said that he has got 16 fewer £1 coins than £2 coins. So my first bar is going to represent the £1 coins. And my second bar, knowing if he's got 16 fewer £1 coins, then that means he's got 16 more £2 coins. So very wonky bar chart. So my second bar represents £2 coins. Okay, and I'm going to draw a dashed line down here because straight away I know that this part of my bar represents the 16 more £2 coins than he's got £1 coins. Now I also know that he has 50 £1 and £2 coins altogether. So the total of both those bar models is 50, and that's the amount of coins he's got, not the value of money, the amount of coins. So we want to find out how many £1 coins Charles has. So this is our unknown. Now I need to remember that he's got 50 coins altogether. So just like our first problem, I'm going to start with this 50 coins and I'm going to take away the 16 extra £2 coins that he has. Okay, and to do this, I'm going to do a quick column subtraction. 50 take away 16. 0 take away 6 can't be done, so I'm going to cross through the 5 to borrow a 10. So the 50 becomes 40, the 0 becomes 10. 10 take away 6 leaves us with 4, and then 40 take away 10 is 30, but remember I just used the tens digit because the 0 would go in place. So 50 coins, take away the 16 extra £2 coins, leaves us with 34. So I can now cross out this part and, let me rub it out, I now know that we have got 34 coins left. But I do need to remember I've still got that extra 16 coins of the £2. So I'm just going to leave that there because I'll need that in a moment. I can then take the 34 coins that we're left with and divide it by 2, which means half, because that will give me the amount of £1 coins and the amount of £2 coins I have, because the bars are equal, remembering this extra 16 £2 coins later on. And 34 divided by 2, I'm going to make some jottings here. I did 30 divided by 2, which is 15. And then I divided 4 by 2 to give us 2. And then added the 15 and the 2 together, of course, to give us 17. Okay, so I now know that the value of this bar has got to be 17 coins, and the value of this bar has also got to be 17 coins. I'm going to change my colour pen in order to help you think about the third step to this problem. Okay, so I now know, using that bar model, that I have got 17 £1 coins. Okay, and that answers my question. I could just leave it as that. Charles has 17 £1 coins. But I want to check that I've still got that 50 coins altogether, just to finish the question a bit more. So in order to check that I've used the 50 coins, if I'm saying that there are 17 £1 coins as the final answer, there must be more £2 coins, because looking back at the original question, it said that he had 16 fewer £1 coins, which means he's got 16 more £2 coins. So I can take the 17 that I've created here, and this is where the 16 extra that we talked about earlier comes into its place. I'm going to add the 16 extra £2 coins together. Okay, and again, I would probably use column addition to support. I'm going to doodle that now for you. Now 7 add 6. Well, I know that 7 add 3 is 10, plus the other 3 is 13. Carry the 10 across, and then I've got 1, 10, 20, 30, 33. So altogether, I have got 33 £2 coins. And the last step in the link is to make sure I still have 50. So if I add the 17 £1 coins plus the 33 £2 coins, 7, 8, 9, 10, carry the 1, 30, 40, 50, he has 50 coins altogether. So even though the answer to the question was he has 17 £1 coins, you can see that the extra steps I've taken ensure that is the right answer, because I've double checked that he has 50 coins altogether. And we know that there are 16 more £2 coins because there are 33 than £1 coins because there are 17, and the difference there is 16. Okay, question number 2. A baker took 2 kilograms of flour from a large bag of flour. He bought a small 8 kilogram bag of flour and added it to the large bag of flour. As a result, the large bag had 21 kilograms of flour. What was the mass of the large bag of flour to begin with? Pause the video and talk to your adult about how you might solve this, what pictures you might draw, and come back to me in a minute and we'll see if you've worked it out in the same way. Okay, year 2s, this one has really hurt my brain, but let's have a go at this together. So, this is one of those questions where you need to work backwards. So we're going to start with the 21 kilograms of flour, and we know that that is the total amount of flour after the 2 kilograms have been taken away and the 8 added. Now, the first thing we need to do is start with the 21 kilograms and take away the 8 kilograms that he originally added. So we're doing the inverse, okay, because it says that he added 8 kilograms to the large bag. So we're going to take it away to give us the amount of kilograms that have been left in the bag. Now 21 take away 8. If you think of a part whole model here and split the 8 into a 7 and a 1, we can do 21 take away 1, leaving us with 20 kilograms, and then 20 take away the 7. If you think about your number bonds, you should know that 7 and 3 make 10, so the answer is going to be 13. So 21 kilograms is the complete weight of the bag. Take away the 8 kilograms that he added at a later date, gives us 13 kilograms. So at the moment, the bag of flour weighs 13 kilograms. However, looking at the beginning of the question, it says that he took 2 kilograms of flour from a large bag of flour. Now, we don't want to subtract the 2. We're going to do the inverse. We're going to add the 2 kilograms of flour, okay, to give us 15 kilograms. So the answer to what the mass of the large bag of flour is at first is actually 15 kilograms. And I'm now going to go back through the question from the beginning, thinking about the bag weighs 15 kilograms to check my answer is correct. So if we started with a bag that is 15 kilograms and we took away 2 kilograms, we would end up with 13 kilograms. Okay. He then bought a small bag of flour that weighed 8 kilograms and added it. So if we did the 13 kilograms that is now in the big bag of flour, because he took away the 2, and we added the 8 kilograms of flour from the small bag that he added to the large, we get 21 kilograms, which of course is the weight of the large bag of flour. Okay, so now because that equals up to what all the facts that we've been given, we know that the original bag of large flour, its mass was 15 kilograms. So if you got that answer correct, well done. Some of you may have completed this in a bit more of an efficient way, and if you know that the baker took 2 kilograms out and then replaced it with 8 kilograms, straight away, if you think about the number 8, you might have noticed that if we took 2 away from that 8, what he's actually doing is adding 6 kilograms to the bag of flour to start with. So knowing there was 21 kilograms altogether, you might have just taken away the 6 kilograms of flour, leaving you again with the same answer, 15 kilograms. Now that was a tricky one that I found really hard to model using a bar model. If you managed it, I would love to see how you managed it with a bar model. For me, personally, this made better sense. Let's have a go at the very last guide. Okay, you need to look really closely at the picture for number 3. It says, look close at the picture. Can you tell me what the mass of the red cube is? So think about the different steps you might need to take to solve the problem. Again, pause the video and we'll come back and talk about our answers together. Okay, this is a nice, easy one, year 2. We can see we've got some scales here, and the red line is directly in the middle of those scales, meaning that whatever the total is of this side of the scales, the balance, is exactly the same as this. Now, hopefully, you would have realised that the first thing you need to do is work out what the weight of the right-hand side of our balance is. And we can see there we've got 3 lots of 25. So we could do 25 times 3. Now I know 2 lots of 25 is 50, plus another 25 is 75. Or you may have done that as repeated addition and written 25, add 25, add 25. Gives you exactly the same, 75. Okay, so we know the total of that part of our balance is 75 grams. So it means that this one also has to equal 75 grams because they are equal. It shows on the balance they are the same. Now, we can see there's only one weight on there, that is 10 kilograms. Now, we know the total of the weight and the red brick has to be 75. So we simply start with that 75 and we can subtract the 10 grams to leave us with the weight of the red brick. Now that should be a nice easy one for you to do using your known facts. 75 take away 10 is 65 kilograms. So the answer is that the mass of the red brick is 65 grams. Now it's your turn to do some independent learning. Read the questions carefully. Remember, the questions get harder as they go on. Sometimes you'll have the calculation you need to do, sometimes you won't. But if you need to make it with practical equipment, please do. Have a go at question 1. And question 2. And question 3. And question 4. Well done, year 2. Today was very hard. Well done for persevering, and I can't wait to see the learning that you get up to. One more session on Wednesday, and then that is it until after the summer holidays when you become a year 3. Have a good